Welcome to Professor Mad, Mathematics for Everyone. Today we are going to talk about the basics of trigonometry. Trigonometry is one of the most important branches of mathematics that finds vast application in diverse fields. Trigonometry simply means calculations with triangles. That's where the tri comes from. Specially, it deals with the right-angled triangles, which contain a 90-degree angle. In trigonometry, we study the relationship between the sides and angles of the right-angled triangle. Trigonometry skills are essential in various careers, including architecture, astronomy, geography, engineering, and many more. First, let's talk about right-angled triangles. A right-angled triangle is a triangle with one of the angles at 90 degrees. We indicate it by using a little box sign. The side opposite the right-angled is the longest, referred to as the hypotenuse. The other two sides are labeled concerning the reference angle. The opposite side is across from a given angle. For example, if you take alpha as the reference angle, the opposite side is AB. If you take beta as the reference angle, the opposite side is CB. The adjacent side is the non-hypotenuse side next to a given angle. For example, if you take alpha as the reference angle, the adjacent side is CB. If you take beta as the reference angle, the adjacent side is AB. Knowing how to accurately label the sides for a specific reference angle is essential. As I mentioned earlier, the triangle is the simplest geometric shape with only has 3 sides and 3 angles. In right-angled triangles, we surely know one is always a right angle. So there are 5 unknowns. If we know any 2 of these, we can calculate others using the knowledge of trigonometry. Before going further, we have to brush up on our knowledge of geometry. The first one is that the sum of all the interior angles of a triangle is 180 degrees. We called this the triangle sum theorem. So if we consider 2 right-angled triangles, the sum of the interior angles of each triangle is equal to 180 degrees. And we already know that in right-angled triangles, one angle is always 90 degrees. So the sum of the rest 2 angles is also equal to 90 degrees. Now assume the angles A and Q are also equal. Let's say those are equal to alpha degrees. Then both B and P are equal to 90 minus alpha. Let's say it's equivalent to beta degrees. Now we can see in both triangles, the corresponding angles are equal to each other, so those are similar triangles. Early mathematicians have identified that, in similar triangles, corresponding sides are always in the same ratio. Now we have a relationship between 2 similar right-angled triangles. This relationship can be separated into 3 parts. Let's rearrange these 3 equations. Are you with me up to this point? So let's clear the rest and keep our last equations. The ratio between 2 sides of a triangle equals the ratio between corresponding sides of similar triangles. This is very useful. It is the foundation of trigonometry. So in trigonometry, we name those ratios according to the reference angle. Let's consider the angle alpha as our reference angle. C and R are hypotenuses. A and Q are opposite sides for angle alpha. P and B are adjacent sides for angle alpha. So the first relationship is the ratio between the opposite and hypotenuse of the alpha angle. The second relationship is the ratio between the adjacent and hypotenuse of the alpha angle. The third relationship is the ratio between the opposite and adjacent of the alpha angle of a right-angled triangle. For any right-angled triangle with the same reference angle, the values of the ratios do not change. We named those sine, cosine, and tangent ratios. Shortly sine, cos and tan. To indicate the reference angle, we wrote those like this. Those are the three fundamental trigonometric ratios. So next time someone mentions a sine, cos or tan, don't be afraid. They are talking about the ratio between two sides of a right-angled triangle in reference to an angle. For any particular angle, there is a constant values for these ratios. For example, let's consider the angle is equal to 30 degrees. For the sine ratio, we get 0.5. For the cos ratio, we get 0.866. For the tan ratio, we get 0.577. These values are the same for any right-angled triangle with a 30-degree angle. No matter what the size and orientation are. If we consider the alpha as 45 degrees, for the sine ratio, we get 0.707. For the cos ratio, we get 0.7072. For the tan ratio, we get 1. Likewise, every angle has constant sine, cos, and tan values. If you have any doubt about this, please try to draw several triangles at different sizes but with the same angles. Then measure the lengths and calculate the ratios of the corresponding sides of each triangle. Each triangle will get the constant sine, cos, and tan values common to every triangle. But we don't have to measure the sides and calculate these ratios every time we need them. There are pre-calculated value tables for those, and most of our calculators come with trigonometric functions. Let's talk about the practical use of trigonometry. Here we have a flagpole. You have to measure its height. It's not easy to measure it from the ground to the top. Instead, we can measure a certain distance from the pole along the land and the upward angle to the top of the tower. To measure the upward angle, we can use a simple astrolabe. Now we know the angle and the adjacent side of that angle. We have to find the opposite side. Here we can simply use the tan ratio. Since we can find out the tan value for the measured alpha angle using the trigonometric table, we can easily calculate the height of the pole. Likewise, trigonometry is very useful in many practical applications. It's essential to memorize the names and ratios correctly. Sine is the opposite divided by the hypotenuse. Cos is the adjacent divided by the hypotenuse. Tan is the opposite divided by the adjacent. There is a simple mnemonic. Take the first letter of each term, and arrange it like this. It sounds like SOHCAHTOA. That's all for today. Share your thoughts in the comments below. Don't hesitate to ask questions. We always appreciate your suggestions. Like and subscribe us for more educational videos.